Hello everyone, welcome to my YouTube class. In this video, we will see what is Luhn algorithm. It is also called as modulo 10 algorithm. Now this algorithm is used to verify or validate the credit card or debit card numbers. Now if suppose this is the example of a debit card number 4567123456789129 and this debit card number is read in the form of a string, therefore at last we have the null character and each individual thing are the characters. Now this is not number 4, this is character 4. Now what do I mean by character 4? The ASCII value of character 4 is 52. The ASCII value of 0 is 48, 1 is 49, 2 is 50 and so on. Now we will do some operations on each of these individual digits. Now that operation has to be done on the number, therefore we need to convert the number we need to convert a character to a number, a character digit to a number. Now how do I convert? Say for example CH is character 4, it is nothing but 52. I need it to be a digit 4. What we do? We subtract 48. Therefore I can say any integer x is equal CH minus 48 where CH is a character digit. Where CH is a character digit. This is how we convert a character digit to an integer. We say CH minus 48. Okay, now we take each individual. Coming to the Luhn's algorithm, what does this algorithm says? It says that take the alternate digits starting from index 0. Now you multiply 4 by 2. When we multiply 4 by 2 we get 8. Now take the alternate digit, it is 6 at even indices 0, 2, 4, 6, 8, 10, 12, 14 and 16. 16 is null, you leave it at even indices. 6 into 2 is 12. Now you say 1 into 2 is 2, 3 into 2 is 6, 5 into 2 is 10, 7 into 2 is 14, 9 into 2 is 18, 2 into 1 is 2. Now after you multiply each and every index alternatively of even position index with 2, check if any digit is greater than 10, greater than 9, and if any digit is greater than 9, you subtract 9 from it. Now is it greater than 9? No, we keep it as it is. Is it greater than 9? Yes, I subtract 9 and we get 3. Is it greater than 9? No, you keep it as it is. Is it greater than 9? No, you keep it as it is. Is it greater than 9? Yes, you subtract 9 from it and you get 1. Is it greater than 9? Yes, you subtract 9 from it and get 5. Is it greater than 9? Yes, you subtract 9 from it and get 9. Is it greater than 9? No, you keep it as it is. Now, what we do after doing all those things? We take the next remaining position, that is 1, 3, 5, 7, 9, 11, 13 and 15. We take those digits as it is. That means this is 5 and we keep this 5 as it is. This is 7, we keep this 7 as it is. This is 2, we keep this 2 as it is. Similarly for this 4, for this 6, for this 8, for this 1 and for this 9. Now after we get this, we add all those digits. We add all those remaining things. Now when I add, what we get, that's where the validation will be. Now if I add 8 plus 5 13 plus 3 16 plus 7 23 plus 2 25 plus 2 27 plus 6 33 plus 4 37 plus 1 38 plus 6 44 plus 5 49 plus 8 57 plus 10 67 plus 2 69 plus. Hello everyone, welcome to my YouTube class. In this video we will see what is Luhn algorithm. Now this algorithm is also called as modulo 10 algorithm. This is used for debit card or credit card number validation. Say for example, this is the credit card number. This is of 16 digits and we are reading it as a string. Therefore it is ending with null character and this is not integer 4. This is a character 4. Right, now what does this Luhn algorithm says? Now we take the digits at the even position. Now what is even position digits? 0, 2, 4, 6, 8, 10, 12, 14. Now we take the digits at even position and multiply with 2. Now 4 2 ja 8. But if you do 4 into 2, if you do character 4 into 2, what will be the answer? Can anyone say? The ASCII value of character 4 is 52 and 52 into 2 will be 104. Right, it means we need to convert this character to integer. Now therefore we need to know the ASCII value. ASCII of value of 0 is 48, 1 is 49, 2 is 50, 3 is 51, 4 is 52. Now if 4 is 52, if I subtract 48 from it, I get the answer as 4. That means any given character, if you subtract 48, where character is a digit, then you will get the numeric value. Then you will get the numeric value. This is the way we get the numeric value. This is the way we get the numeric value. Now, you take the next alternate digit, multiply by 2, 6 into 2 is 12. 1 into 2 is, you have to multiply by 2, okay. 1 into 2 is 2. Next you say 3 into 2 is 6. Next you say 5 into 2 is 10. Now this is also multiplied by 2, okay. 7 into 2 is 14. 9 into 2 is 18. 2 into 2 is 4. And this is where, now after you get this multiplication by 2, you need to check, is there any digit, is there any number which is greater than 9? Is it greater than 9? No, therefore keep it as it is. Is it greater than 9? Yes, you subtract 9 from it and you get 3. Is it greater than 9? No, you keep it as it is. Is it greater than 9? No, you keep it as it is. Is it greater than 9? Yes, you subtract 9 from it and you get 1. Greater than 9, you subtract 9 from it and get 5. Greater than 9, you subtract 9 and get 9. It is not greater than 9. You keep it as it is. Now, you take the sum of this. 8 plus 3, 11. 11 plus 2, 13. 13 plus 6, 19. 19 plus 1, 20. Plus 5, 25. Plus 9, 34. Plus 4 is 38. Now what we do? We take the remaining digits. Now what are the remaining digits over here? The remaining digit is 5. Therefore I take 5. What is the remaining digit? It is 7. The remaining digit over here is 2, 4, 6, 8, 1 and 9. We take the remaining digits and again we find the sum of it. 5 plus 7 is 12, 12 plus 2 is 14, 14 plus 4 is 18, 18 plus 6 is 24, plus 8 is 32, plus 1 is 33, plus 9 is 42. Now after we get this, we add these two, and what is the sum of these two? 80. Now if this number is divisible by 10, then it is a valid credit card or debit card number. Therefore it is called as modulo 10 algorithm. It should be divisible by 10. Right, now you can take the credit card or the debit card which you have and try to verify that it is valid or not with the Luhn's algorithm. Now it should be divisible by 10 means the last digit should be 0. Now again I will explain the procedure once again. Take the numbers at the even position, multiply it by 2, multiply it by 2, and you keep that number as it is. If it is not greater than 9, if it is greater than 9, you subtract 9. You subtract 9. Then you take the sum of this, it becomes 38. Take the remaining digits at the odd positions. Do not do anything. Just add them. It is 42. Now 42 plus 38 is 80. 80 is divisible by 10. Therefore 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 9 is a valid credit card or a debit card number. Now I want you to pause the video over here and try to write down the algorithm and take the debit card or the credit card which you have and try to verify with the Luhn's algorithm. Thank you. Let us now see the implementation of the Luhn's algorithm. We say card of 17 because we know that card is of 16 digit. We say enter card number and we read the card number as string as 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. 9, 1, 2 and 9, and I need to verify that it is correct or not. For this, let us write one function called as validate, or you can give any function name. Let's give one function name called as validate. And what do I need? I need the card number. If it is valid card number, it will give 1 as answer, and if it is invalid card number, it will give 0 as answer. Therefore, we take the return type as int. The function name is validate. The first parameter is character one dimensional array. Now, let's try to write it. Int validate. What is the first parameter? Character one dimensional array. Character one dimensional array. Now what we need to do? We need to take the indices of the even position thing, and I need to multiply this with 2. As I explained, I need to multiply this with 2. Now if I want to multiply, I multiply 4 into 2. I do not multiply ASCII value of 4, which is 52 into 2. Therefore this 4 has to be converted to what? Integer. Now, and at the end we need to find the sum as explained. Therefore we say int sum is equal 0, and let me take one variable int y, and I say I. Now for the value of I starts from 0, it goes up to 16, therefore I is less than 16. Now we will see updation in some time. The first thing is convert this 4, character 4, to integer. How do I convert? Y is equal to card of I minus 48. Card of I minus 48. Now what is card of 0? Card of 0 is character 4. Character 4 means 52, because the ASCII value of character 4 is 52. 52 minus 48 is 4. Now you multiply this 4 with 2. You multiply this 4 with 2. Therefore I can say y is equal to y into 2. Hence the value of y will become 8. Now I need to check if it is greater than 9, subtract 9 from it. Please see the explanation. If y is greater than 9, then what do I say? Y is equal to y minus 9. Now what is the value of y? 8. 8 greater than 9 is false. Do not do it, but you need to find the sum. Therefore we say sum is equal to sum plus y. Now the value of sum will become 8. Please see here. Next time I need to take the value at index 2. Now 0 should become 2. Therefore I is equal to I plus 2. Therefore I is equal to I plus 2. Now the value of I will become 2. 2 less than 16. Yes. Card of 2. It is character 6. Minus 48 is integer 6. The value of y will become integer 6. Now 6 into 2 is 12. The value of y will become 12. 12 greater than 9. Yes sir. Therefore 12 minus 9. The value of y will become 3. Sum is equal to sum plus y. 8 plus 3 is 11. You say I is equal to I plus 2. I becomes 4. 4 less than 16. Yes. Character of 4 is character 1. Character 1 minus 48 is nothing but 1. 1 into 2 is 2. 2 greater than 9. No. Therefore you say sum is sum plus y. 11 plus 2 is 13. Again you say I is equal to I plus 2. I becomes 6. 6 less than 16. Yes. It is character 3. Y becomes 3. 3 into 2 is 6. 6 greater than 9. No. Sum is equal to sum plus y. Now y is 6. 13 plus 6 is 19. I is equal to I plus 2. I becomes 8. Now 8 is 5. 5 minus 48 is 5. It becomes 5. 5 into 10 is 10. It becomes 10. 10 greater than 9. Yes. 10 minus 9 is 1. And 19 plus 1 is 20. Sum becomes 20. I is equal to I plus 2. I becomes 10. Now 10 is 7. 7 minus 48 is 7. 7 into 2 is 14. 14 greater than 9. Yes. Therefore the value of y will become 5. Sum is equal to sum plus 5. 20 plus 5 is 25. I is equal to I plus 2. I becomes 12. Card of 12 is 9. 9 minus 48 is 9. 9 into 2 is 18. 18 greater than 9. Yes. Now 18 minus 9 is 9. Y becomes 9. 25 plus 9 is 34. I is equal to I plus 2. I becomes 14. Now this is 14, which is 2. 14 less than 16. Yes. 2 minus 48 is 2. 2 into 2 is 4. 4 greater than 9? No. Therefore, sum plus 4. 34 plus 4 is 38. The value of I will be 4. I is equal to I plus 2. I is 16. 16 less than 16 is false. That means you have completed with the even position. Now you have to take the odd position. Now how do we get the odd position? We say for I is equal to 1, I less than 16, and again we say I is equal to I plus 2 because the odd position number starts from 1. Now what I need to do? This 5 I have to convert to integer and I have to add it simply. And how do I convert to integer? Y is equal to card of I minus 48, and I have to simply add to sum. Sum is equal to sum plus y. Now card of 1, the value of I starts from 1. Card of 1 is 5. 5 minus 48 is 5. 38 plus 5 is 43. Now you trace it. The value of sum at the end will be 80. Now you need to check, is it divisible by 10? Then a valid credit card number, else invalid credit card number. Hence we say if sum modulo 10 is equal 0, then it is a valid credit card number. We say return 1, else I write here return 0, saying that it's a invalid credit card number. Now the sum is 80, 80 modulo 10 is 0, 0 equal 0 is true, and it returns, and let us store it in some variable v. Now I need to check if the value of v is equal 1, you say printf valid credit card number, else printf invalid credit or the debit card number. This is the way we write the code. The important thing over here is how do you convert a digit to a integer, This is how the Luhn's algorithm work. Thank you friends for watching this video. You may pause the video over here and make the appropriate notes. Please like this video, subscribe to my channel and share the channel with your friends. Thank you.